Hey friends, today I want to talk about Svelte's reactivity. Every now and then I see these posts about Svelte being magic, so for example here where you have this derived and we pass in this function, how is this reactive, right? This must be some magic, or this effect, how do we have automatic dependency tracking in Svelte? And this is something that even Svelte fans get wrong because they often hear on podcasts this is because of the Svelte compiler and etc, when that is not the case. So if you look at this example, we can see we have a beautiful counter here, we can increment it, no problem, we log the value in the console. And this works because of signals. So today we're not only going to learn how Svelte reactivity works, but we're also going to implement signals from scratch. And maybe we'll also look at the Svelte source code later. Alright, so I hope you're excited as I am, and before we get started, don't forget to like, share and subscribe. Alright, so let's talk about framework Andes. So this is the type of Discord I see online all the time. Here we have the React Andy who says about everything, it's magic, but uses the React compiler and obeys the rules of hooks at the same time, doesn't understand the layers of abstraction, says React is just JavaScript unironically, and molds when you say the JSX is a DSL, and DSL means domain-specific language, like a templating language in Svelte. But of course we need to make fun of everyone, so here is also the Svelte Andy. He says, excuse me, it's not magic, it's magical. He uses the Svelte compiler, doesn't understand the layers of abstraction, says Svelte is just vibes, unironically, and he molds when JSX is even mentioned. And of course, then we have the Chad developer. To him, it's just code. He solves problems, isn't afraid of being replaced by AI, and doesn't self-report by complaining about learning. And of course, he dreams about being a farmer. Of course I'm joking, but this isn't far from the truth. Alright, so let's talk about signals and fine-grained reactivity. So here we have the creator of Svelte, Rich Harris. Yes, this is a pizza cone, I had to point it out because everyone gets it wrong. And not only is he the Svelte creator, he made Degit, Rollup, Magic String and so on. So he's really prolific. And in 2019 he made one of the best talks about rethinking reactivity where he introduced Svelte 3, the version of Svelte that became mainstream. And at that point Svelte wasn't really widely used. And people still look at Svelte as this underdog, but it's really a mainstream framework today used by trillion-dollar companies. And over the years, as more people used the framework, they ran into some limitations. So before Svelte 5, Svelte would statically analyze your code to see what had to change, and then it would create a functions for updating the value. But this reactivity only worked inside of Svelte components. So to have reactivity outside of Svelte components, we had to use something like stores. But during that time, as React was gaining more popularity, we had the CEO of Signals, Ryan Carniato, the guy who made Solid, evangelizing Signals. So he didn't invent Signals, but he made them popular. And in fact, he made them so popular that almost every JavaScript framework today uses them. There's even a proposal to add Signals to JavaScript itself. And then in 2023, Svelte decided to switch to Signals. So we have Dominic anyway join Vercel to work on Svelte full time. So Dominic is basically a wizard at JavaScript at compilers, so he worked on React, Lexical and Svelte. So he worked on Svelte for around 2 years to work on the compiler. And since then you have a lot of salty people that say kinda crazy things like, oh, Svelte is just following trends, they're using signals because they're trendy. If I remember correctly, Rich Harris mentioned that they tried like 50 solutions before they used signals. Usually how this works is that the best ideas cross-pollinate around frameworks and at some point everyone converges at the same idea. So it might look like everyone is following trends, but in reality they discovered the best approach to solving a problem. And signals are the perfect reactive primitive for building user interfaces. Alright, so what are signals? Signals are basically observables with automatic subscriptions. So first we have to look at the observer pattern. So this is your pub sub pattern. So here for example we have count, which is an observable, and then we have observers which can subscribe to count. And then when count updates we can send an update. As you can see in this example we have to do manual subscriptions. And this might look familiar if you ever use Svelte stores because they use the same pattern. And you have this pattern in other places. For example, event listeners. So here we have a button where we add a click event listener and then we get the event. Alright, but how do signals compare to the observer pattern? So here we have signals and they have different names like observables, atoms, subjects, refs and so on. So here we have a count signal. And signals on their own don't do anything, so they need effects to react to them changing. So for example, in this example, we're changing the inner text of the element and we have this count text node. And the same is true for the write values. Under the hood, the write values are just effects that return a signal. And again, we have this effect that's going to update the inner text of the element with a double count. And as you can see in this example, instead of using a virtual DOM, you have a constantly updating dependency graph. So each time a value updates, all of this reruns and the dependency graph updates. But of course, this isn't true for all frameworks. For example, Vue uses some form of signals, but they still use the virtual DOM from what I understand. And here is a quote from Ryan Carniato himself. Signals alone are not very interesting without their partner in crime, reactions. Reactions, also called effects, autoruns, watches, or computeds, observe our signals and rerun them every time their value updates. Alright, so after that history lesson, let's understand how Svelte actually compiles code. Alright, so if you have the Svelte extension, you can say show compiled code, and that is going to open the compiled Svelte code. Unlike some other frameworks, Svelte doesn't pretend that it's something that is not. Svelte is a language that extends HTML. So let's say, for example, that we want to create a piece of state called count. You're going to see it's just a regular variable, so it's not even reactive until we actually change the value. And if we create this paragraph tag, you can see that Svelte is going to create the DOM elements required. So we can also say count here. And if you look at the compiled code, it's really that simple. It's actually human readable JavaScript. And of course, the first thing that we learn about reactivity in Svelte is that reassignments update values. So for example, we can say count plus equals 1, or we can say count plus plus, it doesn't matter. As you can see, now the Svelte compiler notices that you're actually changing this value, so it's going to turn it into a signal. And let me actually scroll this code so you can see it better. As you can see here, we have this count, which is now a signal. And as you can see, an assignment is really nothing special. It's just a function call using this set method. So we pass the signal in and we get the latest value of count and then we increment it by 1. But that's not reactive. The actually reactive part is this template effect in the code that Svelte generated. As you can see, this template effect has this setText method, which is going to update the text. And because this signal gets read inside of this effect, it gets updated reactively. Because count is read inside of an effect, is going to add it to its subscribers. You're going to understand how this works completely when we implement signals from scratch. Alright, so let me show you the next piece of magic. So when we use derives, for example, let's say let double, and then we use derived, and let's say count times 2. As you can see, the compiler turns this into a function. And because derives are also effects, they have their own tracking context. So for example, if we create a function, double count, and we can just yoink this code. Let's return it. So now if we go inside of here and say double count and invoke this function, you can see that it really doesn't matter. Because how effects work, the only important thing here is that we read the signal, so it's going to know who called it and it's going to add it to its dependencies. So when double updates, it runs this double count function. And that is why it doesn't matter if you pass a value or not. Because count is not some magic reactive container. We can pass it if you want, but as you can see, it doesn't matter. The only thing that matters is that this function is going to rerun when double updates, because it's inside of a tracking context. And here where we have this effect, this is also what's called a tracking context. And speaking of tracking context, you can create your own user effects. Of course, for that we can use the effect rune. And then we can say console log, and we can track count and double. And as you can see, this works the same way. Because these values are going to be read inside of this effect, and this function is going to be added to their dependencies. So when they update, this function is going to run. And that is the beauty of signals. This is runtime reactivity. This happens live as values update. These dependencies change, and then the dependency graph gets updated. And if this is confusing, don't worry, because next we're going to implement signals from scratch. So you're going to understand how everything works. Alright, so let's delete everything, and I have this special signals.js file. So let's start here. Alright, so let's create a simple signals implementation. Well, first we need to create state, so we can say function state, then we can pass in a value, and then we can create a signal. And basically a signal is just an object. It has this value, and it has subscribers. So we're going to say new set, so they're unique, and then we're going to pass an array by default. And then we need to return the signal, and that's basically it. As you can see, signals really don't do anything on their own. That is why they need effects to react to them. So let's create an effect. So this accepts a callback function. And now we need to track the active effect so we know who called it. So we can say let active effect, let's say null by default. And then we can say active effect equals this function. And then of course we're going to run the effect. So let me explain it so it makes more sense. So for example, if we have an effect where we say, for example, console log, and then we have to say get count, for example. So what's going to happen, we're going to push this function to be the currently active effect. And now when this value inside of an effect gets read, it can check, hey, if there's an active effect, like who called me, then it's going to add the effect to the subscribers. And then later, when we update the value, we can notify the subscribers. All right, so in this case, we can say function get. So we're going to get the value of the signal. And then we can say, hey, if there's an active effect, then we're going to say signal subscribers add active effect. And then we can return the signal value. Awesome. Now we just need to update the effect. So we can say function set. We can pass the signal and the new value. So here's what's going to happen. So we can just say signal value equals the new value. And now we just need to notify the subscribers. So we can say signal subscribers for each, and we can say effect, and we can invoke the effect. And that's it. The only thing that we have to do is export these functions. And that's it. Alright, so let's go back to app.svelte. So let's pretend that this is just regular JavaScript. So let's create a script block. Let's also create our app here. But of course, this is still Svelte, so we have to use onMount. So let's do that. Alright, so just like Svelte, first we need to target the app element. So we can say const app equals document get element by ID, and then we can pass app. And of course, now we need to create the paragraph element so we can add it to our app. So you can say const p equals document create element, and then we can add a paragraph to the app. So we can say app append p. That's it. So now we can create our piece of state. So we can say let count equals state. So this is going to be imported from lib signals. So let's give it a default value of 0. So now we can create the effect. So we can import the effect. And then we can say p text content equals, now we just need to read the signal by importing get, and then we can pass count. So now the function is going to be added as an active effect, and then when we read the signal, it's going to ask itself, alright, who called me, right? And then it's going to add this function to its subscribers. Alright, so the only thing that we have to do is update the signal. And I'm going to be lazy and use a set interval. So let's say 1 second, and here we can import set. So we can pass the count signal and the new value, which is going to be using get count, and then we can say +1. Alright, so let's save and go to the page, and as you can see, it works as expected. And this is the power of signals. Instead of doing manual subscriptions, dependencies get automatically tracked. As you can see, Svelte doesn't do some crazy compiler magic under the hood. Svelte mostly optimizes for developer experience. As the React bros love to say, it's just JavaScript. Alright, and we can even implement a derived. So we can go back to our code here, and under an effect, we're going to create a new function, export function derived. And deriveds are basically just like effects, and they return a signal. So we can accept a callback function, and now here we need to create a signal. So we can say value equals state, and then we're going to invoke this function here so we get the value, and we need to use an effect inside of here. So we can use an effect, and now we need to update this signal, so we can use set, we can pass the signal, and we can invoke the function to get the latest value. And then we just need to return the signal. And that's it. So now we can go back to app.svelte. Under let count, we can create a derived double. So let's say derived imported from lib signals, and then we can pass a callback function. We can say get count times 2. And the only thing that we have to do is update the paragraph with the double count instead. And that's it. So now if you go back to our example, you can see it works as expected. Alright friends, that's it. And if you want to learn Svelte, check out my free Svelte 5 course on YouTube. But before I go, I'm going to leave you with a clip from Rich Harris's talk on Svelte reactivity. And as always, don't forget to like and subscribe, and I'll catch you in the next one. Peace!
So when people talk about signals, they're generally talking about three things: sources, derivations, and effects. Sources contain values. Effects are things that react to changes to those values. Derivations are both values and reactions. When they update when their dependencies change, but effects and derivations can also depend on them. So you end up with a dependency graph with sources at the top and effects at the bottom and derivations potentially in the middle. A source might be something like count equals state 0. Derivation might be something like doubled equals derived count times 2. And an effect might be a function that updates the text content of an element. Or it could be an effect that you define yourself with the effect rune. In a real app, this graph will obviously look much more complicated, but the essence of it is just this. Now, when count changes, we don't rerun effects immediately. Instead, we follow the edges of this dependency graph and mark reactions as dirty, or in the case of a derivation, sometimes maybe dirty because it could reevaluate to the same value. And then we wait a beat, enough time for any other sources to update, but before the browser repaints, and then we run the effects. Sometimes if an effect depends on a maybe dirty derivation, we'll skip it if it turns out that nothing actually changed. It's not quite that simple. We don't just want to run these effects immediately because this text update, for example, could be inside an if block. And if the if block is destroyed, we don't want to have run that code and updated that DOM. In some cases, it could even cause an error if you did that because you could be accessing a property of undefined or something like that. So instead, we put all of the effects in another graph where your root component is mounted at the top and other effects are recursively nested inside it. And when an effect is marked as dirty, like this one, we mark all the edges between it and the root as dirty so that we can traverse the effect graph from top to bottom efficiently by skipping over any branches that we know are clean and preserving the sibling order of effects. There are the effects that you create with the effect rune or effect.pre. There are the effects that update text nodes and DOM attributes. We call these template effects. Things like if blocks and each blocks and key blocks are called block effects, and the things immediately inside those blocks are called branch effects. And if you have an await expression inside a derived or in the template, then that creates something called an async effect. So in the async world, when we process the effect graph, we do it a little bit differently because we don't want anything to update in the DOM while async work is still pending. We still traverse the effect graph from top to bottom, but instead of running template effects or user effects created with the effect rune, we put these into an array. And we do the same thing for async effects. And when we run block effects, instead of putting the newly created DOM, creating the newly created branch into the DOM, or taking an old branch out of the DOM, we create elements in an off-screen fragment and stash the append or remove operation away in a callback. At the end of that process, nothing has actually changed. But we have an array of async effects and an array of template effects and user effects and an array of callbacks. So if we're not waiting for any async work to happen, then we run the template effects and the block callbacks, which brings the DOM up to date. But if we are waiting for async work, then we run those effects and stash all of the other effects away for later. And so when those newly created promises resolve, we mark the stashed effects as dirty, and we do this, repeat the process, and just do this as many times as it takes for all of the async work to settle.